Okay, now we want to have a look at the application of differentiation to kinematics. And we want to do that by studying the motion of a particle. When we determine the position of a particle, which is moving in a straight line, we determine its distance from a fixed point O on the line, which we call origin, and whether it is to the right or to the left of that point O or 0. The average velocity for a time interval t1, t2, so we're talking about a particle moving and that movement takes a certain time, and that interval starts at t1 and ends at t2. And the average velocity of this movement of the particle is given by the change in position over the change in time, which is nothing else than a rate of change. So we're having in the numerator the difference in this case y values, which are called x, and in the denominator we have the difference of time, which is when we have a look at the example in a minute, which you will see that's going to be the x values. x2 is the position of the particle at the time t2, and x1 is the position of the particle at the time t1. So we're having the difference over the position over the difference in time, and that gives us the average velocity of that particle. Similarly to chapter 18c, where we've had a look at the instantaneous rate of change, we can determine the instantaneous change of position with respect to time. That's called instantaneous velocity, meaning if x is the position of the particle at a time t, then its velocity is v, and that's nothing else than the first derivative of v. Later on we will see that we call this velocity or magnitude of velocity also speed, so the v, but that also explains why speed has a v as a symbol. Okay, let's have a look at example 15 here. First of all, here's a graph. You see the y-axis is called x, the x-axis is called t. Okay, so why is that? Because the position of the particle is changing depending on the time which is passing, and we always have the dependent variable on the x-axis, so the horizontal. I don't know why they called the position of the article x, but just don't get confused about that. Right, so we're having a position, or a particle is moving on a straight line, so that its position x at a time is given by this function. X, depending on the time, is t cubed minus 6t squared, and t is supposed to be greater than 0. Because time can start at 0. It's going to be positive, but not negative. Good. So this is now my particle. It's moving down here and back up there. Great. And we are investigating at time, starting at 0, going up to 6. Good. So, question. For what values of t is the particle's velocity positive? Okay, so now we know the velocity. If we have to have a look at the instantaneous rate, that's nothing else than the gradient, right? So the first derivative. Okay, so where's the gradient? 0 here. Yep, must be at 4. Okay, so to the right of 4, we have a positive gradient. So if we have a positive gradient, that means we have a positive velocity. So therefore, the answer to question A is, from the position time graph, it can be seen that the velocity is positive for t greater 0. Okay, and then the other question, for what values of t is the particle's velocity negative? Well, that must be, of course, the other side, right? If we have a look at the gradients of the tangents to the left-hand side of 4 seconds, so between 0 and 4 seconds, we're going to have a negative velocity, which is the answer to question B. From the position time graph, it can be seen that the velocity is negative for 0 or for t greater than 0 and less than 4. Question C. What is the average velocity from particles from 0 to 4? Okay, so we're dealing with this here, 0 to 4. And the average velocity we set to be the difference of x, so the difference in the position over the difference of time. Okay, so here we go. We start with 4, position of 4. We can find that if, by substituting the 4 into our equation, and then we'll see that's not going to be negative 32. Do the same for 0. Well, it's going to be 0. We can see that straight away. So negative 32, subtract 0 is of course only negative 32, and 4, take away 0 is 4. So there we go. The average velocity here for the time between 0 and 4 seconds is negative 8 meters per second. Okay, find the velocity for the particle at t2. So what we want to do is we want to find the instantaneous velocity, and we're doing that by taking the first derivative. So vt is dx over dt. So taking the first derivative of this, and this is what we're getting. And we want to have it at t2, so we substitute the 2 in there for t, and we get negative 12. So at the time t2, the velocity is negative 12 meters per second.